Yeah, good day all together. I'm here in the name of Hazemak Sinoma and introduce to you some best practice procedures for primary crushing installations. So best practice tips with the focus on general operational issues. So issues related to specific equipment design are not part of this presentation, so there is no comparison between different makes or competitor comparison. The content of this presentation is a short introduction of our company, some general aspects, and then in particular tips to apron feeders, feed hoppers, roller screens, and impact crushers. So introduction. Hazemak, in total over the world, we have some 450 employees with headquarters in Dülmen, Germany, 11 subsidiaries around the world, and our main shareholders or our shareholders are Sinoma International and Schmidt-Krantz in Germany. Our applications can be found in minerals processing, cement and aggregates, recycling, and service. And our products are related to comminution, so crushing, screening and feeding, separation, automation, and the test plant.
Hazemak plays an essential role in today's environment and is making a major contribution to people's quality of life around the world. The use of cement and aggregates has an impact on virtually all aspects of our daily lives, including residential and commercial construction, roads, bridges, tunnels, and airports. For the building industry, Hazemak machinery is used in the production of high-quality aggregates and sand, which are valuable raw materials for a multitude of industrial projects. It was in 1946 when Dr. Erhard Andreas founded the Hazemak Company and revolutionized crushing machines and the industries they serve. The Hazemak Andreas Impactor employed a revolutionary yet simple construction design, using a rotor fitted with blow bars and multiple impact aprons. This crushing technique of impacting the material and reducing it along its planes of natural weakness proved highly effective. Today, Hazemak has an installed base exceeding 75,000 machines worldwide and is uniquely positioned to provide its global cement and aggregate customers with the process knowledge, technology, and associated service they require to optimize their operations. For over a century, Hazemak's expertise has perfected the development of innovative, state-of-the-art products and enabled our customers to achieve their project goals. The company's state-of-the-art products with wide-ranging application expertise is acknowledged throughout the cement and aggregates industry. In China, Europe, North America, and many other regions in the world, Hazemak impactors and crushing know-how dominate the cement and aggregates industry and help the production and supply of required high-quality products. Hazemak primary crushing plants with capacities over 4,000 tons per hour are quite common and largely used in a growing business sector. Hazemak's high-quality range of modern equipment is environmentally friendly, designed to efficiency, easy and safe to operate, and delivers optimal and reliable solutions for our customers, whether it's a single machine or a complete processing plant.
So general focus, first of all, primary crushing plants within the cement production is an important step. It's the first step of making cement, but the amount of energy used there is relatively small compared to the energy used for the complete cement production. But even there are some things which helps you to reduce energy, not only energy costs, but together with the energy, also the CO2 emission related to the generation of energy. So first of all, the effect of the run-of-mine grading. The plant capacity depends on the feed size distribution, especially if scalping takes place. So if the amount of scalpings goes down, it affects the capacity of the plant and the crusher load. Typical segregation takes place after the blast. And if no blending is done already in the quarry while loading the trucks, you have different run gradations on the different truck loads, affecting the plant capacity and the crusher load. Sticky materials. Processing of such material is very difficult and care must be taken, in particular during rain season. So also there, certain mix would typically be allowed, but if the content of the sticky material goes up, then you have many problems of clogging and caking in the crusher inlet hood, and that needs to be avoided. Also, too large boulders. It's much easier to separate them in the quarry than first feeding them into the crushing plant, where they can cause damages, but at least they cause stoppages, and you have health and safety issues when removing these rocks. Apron feeders, feed hoppers. The design of the feed hopper plays an essential role for the trouble-free operation of a crushing station, and it must be designed to handle the maximum feed size and sticky material at the same time, preventing mechanical and or cohesive arches as well as rat holes, as you can see here on the pictures. And it must provide the needed bed height and correct flow of the given material to the hopper discharge. So a feed hopper for an apron feeder has a vertical bottom end, which we call shear zone, and this shear zone opens from the rear of the hopper towards the exit. Then we have a so-called exit zone and the extended zone, which is typically called the skirting. Under these conditions, the material is discharged from underneath the pile, and a natural bed height is created at this intersection point from the material to the shear zone, without any additional forces or height restrictions. And that operation saves you already kilowatt hours per ton product. Whereas if you have a too low filling of the feed hopper, the bed height goes down and you increase the kilowatt hours per ton. And if the feed level is too high, it may cause even damages when it's that high as shown here on the picture, damages to the apron feeder, and it causes power peaks and increase the kilowatt hours per ton. General tip for feeding an apron or feed hopper: the first filling should be fine material to absorb shock loads of the large materials, the big boulders. And when you operate the crushing plant and the hopper goes empty, don't empty it completely. Leave the rest of the material inside the feed hopper, stop the plant and wait for the next truck coming. Only empty the hopper for maintenance, then you need to refill it again with fine material. Some skirting is required at the rear end of the feed hopper to avoid that larger stones get into the spillage conveyor. Roller screens. The downstream crusher, or the advantage of roller screens, is that the downstream crusher is relieved through the roller screen. That results in reduced energy consumption, reduced wear cost, reduced dedusting volume, reduced moisture content in the crusher feed, sometimes allowing the use of a smaller crusher on greenfield applications. It reduces operating costs, increases operational safety, and it enlarges the field of applications. So savings, again, are found in the kilowatt hours per ton. And even on an existing plant, brownfield, you may consider retrofit, even though this is always a compromise because of the size available or space available to employ such a roller screen between the feeder and the crusher. If a roller screen is installed, make sure that the skirtings and the inlet are of the same width as the roller screen and not more narrow like shown here, because that's causing the material to jam in this area that can result in damages, and it will increase the kilowatt hour per ton definitely. The impact crusher, you have the effect of the rotor speed, and this is the most contributing factor in impact crushing, and it should always run as slow as possible while still meeting the product size demands. A slower rotor speed results in a coarser product size. A faster rotor speed results in a finer product size. As you can see here on this grading, you see it's always a parallel move of the gradation with the speed. The effect of the front apron. Front apron has also a huge effect. It influences most of the product gradation. A closer gap means a finer product size, and a wider gap means a coarser product size. But you don't move that gradation parallel, you only change the angle of the gradation. But there are limits. A closer gap can also will also reduce the capacity of the impact crusher. Effect of the rear apron. The rear apron has also an effect of the product gradation, but it's limited. It only influences the top size of the product gradation. So you have a bit more control over the top end of the curve. Again, you change the angle of the grading, but only on the last, say, third of that product gradation. Typically, a grinding path is installed in an impactor for the cement industry, and that influences the product over the whole gradation in terms of the angle of the product gradation. Wear. All crushing involves wear, and wear depends on type of material to be crushed, the dampness and feed, crushing degree, material of crushing mechanism, impact crusher load, the manner of the blow bars, the manner of wear of the blow bars. So the material, typically limestone. The most striking factors is quartz, silica content, and the magnesium oxide content. But that is from Mother Nature. We cannot change the feed material. Either operators or we have to live with that material. Typically, limestone applications are low abrasive. On the other hand, a damper feed causes higher wear. The wear can easily be tripled. But if the wear is low in the beginning and you add water, it is hardly been noticed. But if the wear is high already in the beginning and you triple the wear, then it's getting really critical and is not acceptable anymore. So caution against the addition of water for dust prevention purpose. Even a small amount can cause a visible increase in the wear. With a higher crushing degree, of course, the wear increases as well, because the crusher has more work to do, and therefore also the amount of power, the kilowatt hours per ton, goes up with the crushing degree. Material of crushing mechanism. Usually in a primary impactor, manganese blow bars are used. This material is so-called work hardener. So with a decreasing impact stress and an increasing friction stress, the wear resistance of this material group decreases. There is a subgroup of that material available with less chromium content, but titanium instead. The advantage is that the titanium carbides, or the distribution of the titanium carbides, is more even than the distribution of the chromium carbides, and there are some 30% more carbides formed within the blow bar, so they are more wear resistant. In certain applications, but really this is limited and needs to be checked, cross-checked. Sometimes we can use martensitic steel for the blow bars, or a manganese steel with carbide nails, like shown here on this picture. So, impact crusher load. What happens when the feed volume increases above the rated limit? Well, the product size gets coarser. If the crusher would operate in closed loop, which is typically not the case for the cement plant, the recirculating load increases, the reduction ratio decreases, the demand for power increases, blow bar life is reduced, and in general, maintenance and downtime is increased. Whereas if the crusher would operate below the designed capacity, the product size gets finer, the recirculating load decreases, the reduction ratio increases, the demand for power decreases, the blow bar life is extended, and in general, maintenance and downtime decreases. So an impact crusher has the lowest wear cost per ton when operated at designed capacity. Either overloading or underloading will increase the wear cost per ton. And that refers also to the cost savings in energy. And I would like to remember the first slide, the ROM gradation and the effect of the ROM gradation to the capacity of the crusher. Then we look at the wear along the length of the blow bar. You see here on the picture a blow bar that wears much more in the middle than on the outside. It would be the best if it would always be 100% straight, but this can never be achieved. So you have some hills and valleys. But if the wear is increased, like on this picture in the middle, the cause is often an insufficient load. Another cause can be that of water and or the crusher is not being fed over the full width of the crusher. If the wear increases on the side, so the opposite picture, then it's usually a result of overloading. And last not least, the wear through the cross section. If the rotor is running too fast, then the material is hitting the blow bars on the top, and you have a lot of friction wear and ineffective wear, which is not used for crushing. So you need some penetration into the rotor circumference, and that is typically shown in a beautiful curve on the blow bar cross section. Then you have optimum wear on the blow bar. Thank you for attention. Now I close the presentation and I'm open for questions. So first question is, can the configuration of the crusher be optimized for different milling systems to minimize the overall power consumption in terms of kilowatt hours per ton cement, or is there no relationship between milling system and the optimum setting of the crusher? First of all, there is definitely a huge difference between the vertical roll mills and ball mills. They require a completely different maximum feed size and feed size distribution. So a ball mill typically requires a D95 of 25 millimeter, which can only be achieved by either a hammer crusher or a what we call compound impact crusher that has two rotors in the crusher. Whereas if you are using a vertical roller mill, the feed size typically is somewhere in the region of 95% passing 80 millimeter. So within certain limits, you can adjust the product gradation, but you cannot change it to suit either a vertical roller mill or a ball mill. That is not possible with the same impact crusher. The next question is, how can crusher design help to reduce material blockage problems, especially where the limestone is mixed with clay and moisture is too high? Okay, there are the first thing is change the. I assume you don't have a clay crusher separately, and you don't have two different feed hoppers. The ideal thing is either to have a clay crusher and a limestone crusher, or you have two different feed hoppers, one for the limestone, one for the clay, and you can regulate the amount of the two materials with the speed of the apron feeder. If you can't do this, if you only have one feed hopper, you have to take care that in particular when the clay gets sticky, you use large enough limestone to that the overall moisture in the mixture would fall below 6% on average, and then it will most probably work. If this all doesn't work, there are two more options. Either an impact crusher can be retrofitted with a heating system for the inlet base plate and the impact aprons. That is pretty expensive, but it helps a lot. You can go up then to 11–12% water content in the feed. And or to employ a roller screen, a scalping system in between the apron feeder or the impact crusher.
Okay, so that's all the questions that we have. So thank you very much for presenting, Stefan.
Thank you for the opportunity to have that speech.
Great. And thank you to everyone who attended, and we'll be ending the session. Thank you.
Okay. Thank you very much, and stay safe all together. Have a good day. Bye-bye.